फिजिकल मतलब चल रहा है।
ओके
ओरिजिनल बनने में थोड़ा टाइम लगेगा सर, अभी सर बोल रहे हैं कि नोट्स करके चल रहा है। ठीक है
ओके वेलकम एवरीवन and good morning to all of you.
क्या नाम है?
Good
I am
morning.
Jadendra, PhD fellow from NIT Rourkela. I am welcome you to everyone for IEEE 2024 conference. I am welcome sir Shubham Kanti Dhar. We are very much grateful to you are here. You will be our chairperson for this session. Dr. Sohan Kantidhar is an assistant professor in the Department of EC in NIT Rourkela. He completed his MTech from the Department of EC, NIT Rourkela, and gold medal from the MTech, and did a PhD from the Department of EC at IIT Kharagpur. Thank you, sir, to be here. Now we'll start the session from one by one according to the schedule. The paper ID having 177, you will start from 177 and up to 230. In serially, we have to present. Everyone will be given 8 minutes of presentation followed by a 4-minute question answer. Okay.
Yes, so thank you for briefing the Jaydev. Anyways, Jaydev told please maintain the timing strictly, and I welcome all of you to the sessions. We should have a nice interactions, but try to maintain the timing that is given by the coordinator here. Okay, carry on, please.
Okay.
Yes, sir.
Okay. Having paper ID 171, you can start your presentation.
Yes,
you can share
yes,
your
sir.
screen.
I am. Yes, sir. Let me share the screen. Yes.
Okay.
Is my screen visible, sir?
Yes, sir. You are yes, sir. You are visible. Go ahead.
Yes, sir. Good morning, everyone. I am Dr. Jitendra Kumar Sao. My paper ID 177, and my title for today's presentation is Analysis of Direct and Indirect Current Controller Techniques in PQ Theory-Based Shunt Active Watt Filter. These are the contents of my presentation: introduction, literature survey, objective, methodology, and the main comparison of ICC and DCC methods, and then result and discussion, and at the end, conclusion and references. So our power quality is very important. As we know, poor power quality may damage sensitive electronic equipments. In the home appliances, it may cost thousands, but in the industry, poor power quality cost millions of losses in the industry. So there are various power quality issues like harmonic distortion, voltage sag, swell, fluctuations. Out of these various power quality issues, harmonic distortion is one of the major concern for the industry point of view. So we have addressed the harmonics in our research. So these are some common sources of harmonic generating sources like arc furnace, variable speed driver, various types of rectifiers, converters. Because these are electronics devices are increasing day by day. Hence, there are power quality issues are. So we need to mitigate the harmonics. There are two kinds of mitigation techniques. We can broadly classify into two categories: passive filters and active filters. Passive filter, as name suggests, it is made up of passive elements like inductor, capacitors, and hence it is bulky in size because of the presence of inductor, and because of presence of capacitor and inductor, this may cause resonance problem also, and it provides fixed compensation because we have fixed components. But on the other hand, we have some advantage over passive filters in active filters, like we can provide variable compensation. This is comparatively smaller in size, and no resonance problem in the active filters. So we have performed our literature study to study the active power filters. First, we have studied the various power quality issues. Then we have studied the review of active filters and what are the different kinds of their configurations and where they are used. Then we have studied the various control strategies for the active power filters. So these are our literature survey, and from this literature survey, we have found that these are our objective. We want to design a shunt active power filter which can provide the adequate harmonic compensation. And there are basically two kinds of current controller techniques: indirect current controller (ICC) and direct current controller. So here we will try to compare the performance of both the techniques. And from literature, we have also found that for reference current generation, IRPT, instantaneous reactive power theory, is one of the most common, most popular methods to current the reference current generation. So we have used the IRPT technique for reference current generation. So shunt active power filter is nothing but the DC link capacity, a three-phase voltage source inverter. Phase shunt active power filter. Here we can see the source current from the grid, and this is the non-linear load. Because of the non-linear characteristic, it draws the non-sinusoidal current from the source and hence generate the harmonics in the whole power system. But if we attach a three-phase voltage source inverter with proper switching techniques, then it can provide the compensating filter current which suppress this generated harmonics by this nonlinear load, and hence mitigates the harmonics and provide the smooth sinusoidal current from the source. And this three-phase voltage source inverter is nothing is backed by the reference current generation current control techniques, and these tools are help them to proper switching operation of this voltage source inverter. So these are the basically the reference current generation technique for switching pulse generation. This is the block diagram. Here we sense three-phase voltage and current and apply the Clark transform, which converts the three-phase voltage and current, which is in ABC domain, to the alpha beta domain. And we calculate the power, active and reactive power. Then we pass it to the low pass filter to separate the harmonic power and other power. Then we apply the, and we get the reference currents. This reference currents is basically used for the switching pulse generation, but we can generate this reference current by two current controller methods: indirect current controller and direct current controller methods. These are basically the block of. As we can see that indirect current controller method, in here we reference current generation is generated by the source voltage and source current, directly source current from the here from the supply, and this source current is used for the switching pulse generation by using the pulse width modulation techniques. But in direct current controller, this source voltage is not used, either load current is used for the reference current generation, and then this source current from the from here PCC, here it is used for switching pulse generation. So this is the block diagram of ICC and DCC techniques. So we applied these two techniques and try to find out that how this compensation is works. So this is our simulation model. This is our Simulink model of our shunt active power filter. Here three-phase supply. This is non-linear load, and these are the some oscilloscope for observing our signals. See, these are the simulation parameters that we have used for this simulation. And when we applied ICC methods, then to observe the effect of shunt active power filter, what we have done, initially we turned off our power filter till 0.5 seconds, and after 0.5 seconds we have turned on the shunt active power filter. So here we can see this figure A is the source current. So we can see the till 0.5 seconds there is a huge harmonics. It is not sinusoidal. It is a lot of harmonics is present till 0.5 seconds. But after 0.5 seconds, we have turned on the our shunt active power filter through switch. So after 0.5 seconds, it significantly suppresses the harmonics, and it tried to become the sinusoidal. That means harmonics are mitigated. Figure number B is the filter current. Since we turned off the our filter till 0.5 seconds, it hence it is 0 till 0.5 second, and after 0.5 second it provides the compensating filter current which suppresses the harmonics. And this is the load current. Since we have non-linear load, hence it throughout draws the non-sinusoidal current from the source. Yes, sir. And this is the simulation result for the DCC method. Here also we can see that it also provides the adequate compensation, and this also provides the decent compensation. But from the FFT analysis, we have found that before applying the shunt active power filter, our total harmonic distortion was 21.57, and with ICC method we have reduced it till to the 2.38%, and with the DCC method we have reduced it to the 2.43%. So we can see that both methods, ICC and DCC, provide the decent compensation, but ICC methods provide slightly better compensation as compared to DCC method, because it reduces to the 2.38, and in DCC we have got the 2.43. So these are the conclusion of our slide, that for shunt active power filter provide the decent compensation with proper switching pulse generation techniques and current reference current extraction techniques, and both the methods provide decent compensation, but our ICC method provides a slightly better compensation, which we can verify through our analysis results. And these are our references that we have used. So that was all about my slide.
Thank you, sir. Now we are open for the query. Any participant from query or sir?
Okay, so it's a very nice presentations, and you have completed.
Thank you, sir.
Time. I have two fundamental questions. Like, what is the novelty of your work? Like, there are existing works in the similar domain, right?
Yes,
so
sir.
how this work is different in respect to them, and your potential impact to carry forward this researcher to the next level?
Yes, sir. Actually, there are basically, sir, there are different methods. Many researchers have used the ICC methods. Many researchers have used the DCC methods, and they have performed the similar work. But compare these two methods, so that we can, for the same scenario, if you use both the methods, then which performs slightly better or slightly less. My research is basically the comparison type of method, comparison of two methods.
But if you check your comparison, do you compare with the recent work in the domain, like the latest research? Because I can see those techniques are a bit old, right? Or not state of the art, so that you can consider for your next level of research, right?
Yes, sir. Yes, sir. Yes, sir.
Okay, fine. No more question from my side.
Okay. Thank you, sir.
Any question from participant? Okay, then, sir, you can stop sharing your screen. Now 180.
Okay. Thank you, sir.
Thank you, sir. Now paper ID having 183. You can share your screen and start presentation.
Okay, sir. I'm sharing my screen. There is screen visible?
Yes, sir, visible. You can start.
Good morning to all of you. My paper ID is 183, and name is Future Prospect of Agriculture Using IoT and Machine Learning. My the authors are Arindam Mandal, Prosenjit Dev, Santosh Probakar, Amit Kumar Jha, Nilendra Rocky. I am the Sudipta Ajra presenting this paper. Now, what we are doing this in this particular scenario, actually, agriculture is very much important for our life. So due to that, we try to do something that earlier work, whatever done traditionally in agriculture, and nowadays also the introduction of the machine learning and IoTs. What are the impacts? We try to prepare some survey on that, and from that we got that in earlier traditional farming technique, there are so many negative issues for that, the production as well as the cost of the farming is quite high. But when we introduced the technology in agriculture, then we got some positive result. So the main motto is that to how we use that technology in agriculture so that the farmer will get some benefits as well as some profits from their agriculture purpose. So the presentation purpose of this presentation is to explore the role of IoT and machine learning in agriculture in today's world, and we try to discuss the future prospect and potential impacts on that agriculture or farming or precision farming, so that farmer can get benefits on that. This is two parts of my research survey. As we try to do some survey work on this particular scenario, we got that in real-time monitoring system by which we can monitor the soil moisture, temperature, or weather, various scenarios, so that the agriculture may get some benefits, as well as the energy harvesting plays a critical role in agriculture. Also, the weather has a significant impact on the agriculture. So, for weather product, if we get the weather prediction earlier, so it will be easier for the farmer to get some higher performance for crop production. And the use of the IoT and machine learning AI will get benefits for the farmer, but there are some drawbacks also. So when we try to apply some IoT and machine learning combined, the precision agriculture may be fruitful for the near future. So objective of our survey is that we have tried to focus how we increase the efficiency by how if we automate the process, so it will reduce the labor cost. Like modern tools, if we used on that particular farming, that will reduce the labor cost. Also, it will optimize the resource use. Because when we plant and use some particular IoT tools, that will optimize the resource use, and then we try to focus on the productivity enhancement, and another one is we try to reduce the environmental impact, and as well as the conservation of the water and other resources, as without proper plan, so many water resources are unused and they are not used properly. So we try to also focus on that, so that the water wastage can be reduced. So few case studies.
Can you go fast? Only 3 minute labs. Okay.
Okay. So by that we will do some how we'll use the maintain the soil moisture and plan for the what particular product will be suitable on that particular area, what fertilizer we will use, what type of pest management we will use. These are the scenario by which we can increase the productivity of the particular field area. We go for so many papers, and from that we got that most of the papers they have studied according to their study. So two particular methods came into the scenario. One is SVM and another one is CNN, support vector machine, and another one is convolutional neural network. And by that SVM we got the performance nearly 75%, and in one particular reference, and another in that same reference we got by CNN around it is 89.13%, and by another research we got the scenario. By that SVM give the accuracy of 83.3%, and by CNN it gives 92.7%. And in few more discussion we got that how the production can be increased by predicting the humidity, rain, what are the possible risks will come, what are the scenario if we apply the recent IoT device. So it can increase the productivity, but it is quite difficult to implement in the lower level, as the farmer are not able to get this all this support properly. So how will make this available to the lower level farmer, so that they can get the proper idea and application of IoT and machine learning, so that they will get the proper farming. So this is the conclusion. So the amount of agricultural land actually gradually day by day it is decreasing, and due to so many causes. In that there are natural cause as well as the human-made cause. So we have to think about the farming, so that our agricultural land must not be reduced. So based on this agriculture, the human society are day by day or also depends on that particular area. So we are focusing on that also, as well as we have tried to assess the use of IoT and machine learning in precision agriculture, so that it will emphasize on that particular area, and the farmer will get some support from in lower levels, so that they can apply it in their area. And lastly, it is quite difficult. We think that is try to implement in lower level in without the proper support of all the local governments. So unless or until we'll apply it in the lower level completely, we'll not get the proper precision agriculture. And if we can get some more challenges, so, and we have to try to reduce the cost of the IoT device, and machine learning supports them, so that they can use it without a minimum cost.
Thank you, sir.
These are the references we have used, and from this actually we have tried to do some work, and based and before that work we have go for a survey, and from that survey we have prepared this research paper, and our plan is to work on that and to prepare a device so that it will do some particular work or what we are planning for this.
Now we'll start question answer session.
Okay,
Up to Suvan, sir, please.
Okay. So first of all, in general, I again want you to tell you that please try to maintain the stipulated time given by the coordinator. Anyway, so coming to the presentations, see, such kind of precision farming is really need of the hour, and people have worked a lot on this. But I want to know how, in what way your work is different from others, because almost you are doing a similar thing. And from machine learning perspective, what way you are like, what novel contribution that you have in that domain?
Actually, sir, in this particular research, there is no novelty in our paper. We have actually go for the study, and I have go for so many papers. From that paper, we have prepared this survey report, and based on the survey report, I have prepared this paper. But actual idea is that we are trying to build some IoT device which will be an cost-effective with minimum cost and using the technique of machine learning, so they can easily uh, try to manage and manipulate the data of the earlier of that
That I
particular
understand.
area.
My question is like, do you have any specific notion on that? So even if it is literature survey, what way you can make the things lighter, what the way you can make the things better. So your research title is future prospect. So I want to know the prospect that you have studied. Any specific outcomes?
Yes, actually, sir, we have initially worked on 2.3 ideas. At least that can get minimum cost from the farmer, and that will check the moisture of the land, soil, and based on the crop, what kind of the pest they can use based on the earlier data in that particular area. Initially, we are working on that.
Okay, fine. No more questions from my side.
Thank you, sir. Now you can stop sharing the screen. Thank you for presentation, Suvit sir. Okay. Now paper ID having 191. You can start your screen sharing and start the presentation. And please stick to the time. 8-minute presentation and 4-minute question and discussion.
Okay, sir.
Please continue.
Good morning, sir. Here I'm going to present you on the topic removal of noise in color images using convolution neural network. So the contents are introduction, literature survey.
Make it full screen, ma'am.
Is it visible, sir?
Yes, yes, ma'am, visual. Okay, you can continue.
Objectives, methodology and novelty, results and discussion, conclusion and future scope, and references. So, in the ever-evolving field of digital imaging, the integrity and quality of images are paramount. So, however, one of the significant challenges we face is the introduction of noise during the acquisition and transmission process. So, this noise, which can manifest as random variations in brightness or color information, leads to degradation in image clarity. So, such degradation is in critical applications like computer vision, medical imaging, where the precision and accuracy of image data are crucial. So we have gone through various papers, so in which these we have identified these as our base papers. So in the first paper, the researcher examines various deep learning methods for removing noise from images. So he categorizes these methods based on the types of noisy images they can handle. So this study addresses real world issues like complex and irregular noise, blurry and low resolution image, and also the lack of reference images for training. So he highlights the need for effective noise removal strategies and suggests directions for future research to improve these techniques. And in the second paper, uh, he introduced an innovative method using autoencoders to remove noise from images without needing clean images for training. So this method learns from noisy images and can still perform well without prior training. The experimental results show that the approach works better than many existing methods, especially in situations where there is limited training data. So, uh, even though previous methods have performed well,
I think you are not changing the slide, I guess.
I'm changing, sir.
Okay.
Can you see the objectives, sir?
No, not visual. It's content page only. Can you reshare again?
Yes.
Yes, now I can check.
Even though previous methods have performed adequately in addressing image noise to some extent,
And
however, sir,
your screen is not visible. You share it.
is it visible, sir?
Yes, ma'am. You can continue.
So even though previous methods have performed well in addressing image noise to some extent, here our objective is to significantly enhance image quality by introducing a novel method using autoencoders with CNN, that is convolutional neural network. So this approach aims to surpass the existing standards by focusing completely on improving image clarity through advanced neural network techniques, and also to improve performance metrics of images by calculating mean square error, peak signal to noise ratio, and structural similarity index. So coming to the methodology, so traditional noise reduction methods, even though they have performed to some extent, even though they, sir,
it's showing objective only. Your slide is not changing.
Please go to your block diagram and explain that part.
so we have taken CFAT10 dataset for our model, and the image is of size 32 by 32 with 3 color channels, RGB. So this model which we are building is an autoencoder model. It has encoder and decoder. So the encoder compresses the input image into lower dimension representations. So firstly, we have used a convolution layer. So it has 32 filters of size 3 by 3 with a ReLU activation function. And the padding is used the same, ensures that the output has the same dimensions as the input. And we have used a max pooling layer. It reduces the spatial dimensions while maintaining the depth of the feature maps. And again, we have used another convolution layer, which is of 16 filters of size 3 by 3. And again, ReLU activation function. And then
Yes, I can see
and
this one. Can you please go to directly your contribution part and regions?
We have used Google Colab as a cloud-based. It is a cloud-based environment. We have used Python to in our model. So we have used CFAT dataset, we have introduced a noise of 0.1 noise factor. So the first row, we can see that the images are noisy, and in the second row, we can see the denoised images of our model output. So here in this graph, we can see that as the epochs are increasing, the training loss has been decreased. So we have used an epoch of 100 in our model. After the epoch 100, the training the loss has completely gone, and we can get the complete image with a full clarity. So we have calculated mean square error, peak signal to noise ratio, and structural similarity index. So the ideal value of mean square error should be ideally 0. So it was like nearer to 0, and peak signal to noise ratio. So the ideal value can be greater than 28. And we have also measured structural similarity index. So the image clarity is said to be good when the structural similarity is nearer to 1. So coming to conclusion, removing of noise in noisy images is crucial for making images look better and easier to analyze. So convolutional neural networks are great at this. They can understand a lot of details in each pixel. So we have used autoencoders. It really improves how clear and accurate images become in various uses. So as we keep studying and developing this technology, we'll likely make better ways to remove noise from images in the future.
Thank you, ma'am.
These are our references. Thank you.
Okay. Thank you, ma'am. Now we'll start question and answer session. Up to the sir.
Actually, I have two fundamental questions. First one is, see this basic CNN architecture that you have used, DenseNet, right? You have
Autoencoder.
Autoencoder. Huh. So what is the dense layer? Dense 1, dense.
So dense layers are they are fully connected layers, like
No,
where each neuron.
There is already fully connected layer is there, all right? Flatten one.
Yes, sir.
Right. So what is this dense? I'm asking about dense one.
So they allow the network to learn complex representations and make decisions like based on the combined feature extraction by convolutional layers.
In this, there are a lot of work on this domain. Huh? Did you compare with the latest state of the art in the domain? For example, and also this you have used CIFAR, right? CIFAR datasets.
Yes, sir.
So that is a very small size datasets. I mean, small size means image size are smaller. So did you work on like standard size, say for example 512 cross 512 or HGT images or any other format?
No, sir. We have only used the CFAT and dataset, and we have in testing it has performed well on all of the images. Sir.
Can you go to the table? Comparison table.
Yes.
Yes. So as you show, this is the results of different images. So this is performance in testing time or training time?
Testing time, sir.
Testing time. Okay. So did you compare this result with any other technique? I mean, how do you quantify your results with respect to the recent one?
So we have gone through literature review of many papers where like the PSNR had varied between 25 and 30 and not more than that. So in our paper, we have got the results for some images 30 and for some more than 30. And also we have got a better mean square error. So.
Okay, fine. I don't have any question.
Thank you, ma'am. Okay, now we'll go for the next session. Paper ID having 192.
Yes,
You can
sir.
start.
Am I audible, sir?
Yeah, you are audible. You start your
Yes.
start presentation.
Yes,
Try
sir.
to uh, stick to the 8-minute presentation, sir. Please.
Okay, sir. Is my screen visible, sir?
Yes, sir. It's visual.
Good afternoon, respected dignitaries. Today I am here to present my paper, Remote Sensing Images Enhancement and Object Detection using Deep Learning Techniques. Coming to my contents are Introduction, Literature Survey, Objective, Methodology and Novelty, Results and Discussions, Conclusion and Future Scope, References. Let us get into the introduction. Coming to the introduction, today remote sensing images play a huge role in detection in military use and in landscape detection. So the main disadvantages of using remote sensing images we are facing today is that noises, different types of noises incurring while the sensors are taking the pics of remote sensing images. There are different types of noises like Gaussian noise, sensor noise, and atmospheric noises, etc. And not only that, while the sensors are detecting the remote sensing images, there is a lot of clarity issues in the images. So our focus in this paper is to how to tackle with the problem of noises and image clarity in remote sensing images for object detection in it. Coming to the literature survey, generally we use convolution neural networks for the object detection in various images. So here we are taking YOLO V5 as object detection thing, and coming to generative adversarial networks have a lot of use in today's life, as generative adversarial networks will be helpful to enhance the quality of the images in various conditions like underwater and etc. So these are our paper references. And coming to our objective, our objective is to enhance the given image, and not only that, we will also try to remove the noise as much as possible in the image, and also use the images to detect the image. For example, if if our satellite is capturing 100 pics, in that if we have 90 pics which are blurred and noisy, we can remove the noise from the images, and also we can enhance the image quality using generative adversarial networks, and we can detect the objects in it for the accurate detection of the objects. Coming to our methodology and novelty, our methodology is, in this paper we are trying to integrate two different types of deep learning techniques. One is enhanced super resolution generative adversarial neural networks with YOLO. YOLO is a convolution neural network which is helpful to detect the objects in an image. And coming to enhanced super resolution generative adversarial networks, they are very helpful in enhancing the image quality up to 4x times than the original image. And here we are using OpenCV module to remove the various types of noises in an image, and not only that, we are also sharpening the image to remove the edges in it. And coming to the novelty, generally these days generative adversarial networks are not used in remote sensing images, but our idea is to bring generative adversarial networks into the into enhancement of images of remote sensing images. And not only that, we want to integrate OpenCV with ESR or GAN to remove the noises, so that we can solve two problems in one network, and we will give this output of this ESR GAN to YOLO, so that it will detect the objects in a more accurate way. Coming to the results and this is our block diagram. Generally, generative adversarial networks works in a process that we will give an image as a real data sample to the generative adversarial network, and it will generate a random signal by using random variables. Generator generally generates the signal, and this generator signal and real data sample gets into the discriminator, so that discriminator compares between the generated signal and real data samples, and it will be it will takes a decision that it is correct or not. So that if it is correct, then it will go to the generator and it will get a reward point. If it is wrong, then it will get a negative reward point, so that it will change the generated a signal into a better way, so that it will compare and it will give a final output which is much better than the real data sample. So that this input, this not correct, this correct input is given to the YOLO algorithm, so that YOLO algorithm will detect the object in the much clear image than the original image. Coming to our results, this is a normal image and this is a Gaussian blur image. Generally, we have taken Gaussian blur image because generally Gaussian noise is the noise which is equal to the noise present at the sensor level of a satellite. So we have took example as a Gaussian blur image. This is the Gaussian blur image. You can clearly see the difference between the normal image and Gaussian blur image. And coming to the difference between the enhanced Gaussian blur image and Gaussian blur image, this is the difference. There is a lot of difference between the clarity of the image in Gaussian blur image and enhanced blur image. And this is normal image and this is enhanced Gaussian blur image, which we get output of a GAN, ESR GAN. ESR GAN generally resolutes and it enhances the quality of the image up to 4 times. This is the peak signal to noise ratios, which is a characteristic to determine the image is enhanced or not. This peak signal to noise ratios of various types of noises. This is Gaussian blur. The enhanced signal has 36.79, but the original image has 33.58. These are the various values of median blur, blur function, kernel blur, etc. Coming to the object detection, YOLO V5 is a convolution neural network which is formed based on the darknet 53. So this is the this is the way how it will detect the. Generally, YOLO V5 takes the intersection or union of the object and it will bound the boxes localization. After localization, it will detect the objects clearly. We will take the various measures for detection of accuracy to measure the accuracy and precision. So coming to those results, this is the training data losses. This is class loss, which is the training classification loss, and this is training object loss, and this is training box loss. Box loss is a general measure that while we are localizing an object, if the object comes out of the box, then it will be shown as a loss in the algorithm. Coming to the validation dataset, this is the validation dataset losses we have taken. And coming to the metrics we have used, precision is a metric which is used to tell that the clear which is used to determine that the clear precision and marking of the object. Coming to mean average precision is taken over a threshold value. General threshold value of YOLO is 0.5. Here this metric shows for 0.5. And we have also taken a threshold value of intersection over union for 0.5 to 0.95. This is the graph for that. And this is recall metrics. Coming to the conclusion, if the images are unclear and having low resolution, we cannot clearly detect the objects, so that it will cause a failure in the operations, like for military operations and geographic operations. So the images must be very clear for the clear object detection. So our motto is to create a clear images from the unclear images, and not only that, this has very high future scope as the AI is developing day by day very rapidly, and not only that, convolution neural networks also creating wonders in this society and nowadays. So AI can create much wonders with the combination of generative adversarial networks and convolution neural networks. Thank you. These are the
Thank you.
references of our paper.
Now we'll start for question and answer session.
Yes, sir.
So, one sir, please.
Yeah, this is a really nice topic, and you have a nice presentations along with detailed discussions and analysis. But I find no such comparison with the recent state of the art in the domain. Okay, so did you compare your work with any other work that is published already?
Yes, sir. I have read many papers, sir. Generative adversarial networks are used underwater detection, underwater clear enhancement of images, etc., sir. So my idea is to use generative adversarial networks for remote sensing images, sir. Generally, these days, remote sensing images are being detected by only using convolutional neural networks, sir. There is no
No,
enhancement.
in fact, using generative AI, there are a lot of work. Okay, so I want to know, like, did you compare with, say, for example, recently you have diffusion model, right? Also, so did you compare with any other techniques to showcase how good your techniques is with respect to them?
Actually, no, only there is noise removal, sir. So they haven't used till now generative adversarial networks in remote sensing images, sir. So I could not get any comparison.
Okay, so go to the table, the results quantitative evaluation piece and all.
Yes, sir.
Yes, so you have shown some results. This is a result on one images or multiple images?
Sir, from multiple, this is for the image I have kept in the example, sir. But we have two tables for multiple images, sir. We have compared every image.
Okay, so that kind of analysis should be there. Like it may work for one single images, it may not work for others. Okay, so yeah. Okay, fine. I don't have any other question.
Thank you, sir.
Thank you, sir. You can stop sharing.
Yes, sir.
Now, paper ID having 216, you start sharing your.
Yes, sir, I am audible. Am I audible?
Yeah, yes, ma'am, you are audible. You can start sharing your presentation and start the presentation.
Is the screen visible?
Yes, yes, ma'am, it's visible. Please start.
Good afternoon, everyone. I am Safana Rafiq. Today, I am going to discuss about the topic MobileNet enhanced skin cancer detection and classification using dermatoscopic images. These are the contents we are going to discuss about. First one, the introduction. Let's move on to the introduction. Skin cancer is the most perilous forms of cancer, which is a pivotal means to reduce the associated fatalities. Basically, detection is done by biopsy. It is laborious and time consuming. So we are introducing a deep learning model which not only detect as skin cancer, it also classifies which type of skin cancer it is. And this method improves the speed, precision, and accuracy of the diagnosis. These are the literature reviews we are referred. In the first paper is MobileNet V2 model for image classification. It has an accuracy of 86.03% and the skin laser analyzer, an efficient 7-way multi-class skin cancer classification using MobileNet. It has an 83.1% of accuracy. And the next one has a classification of skin disease using deep learning neural networks with MobileNet V2 and LSTM. And it has an accuracy of 85% and intelligent skin cancer detection applying autoencoder and MobileNet V2 and spiking neural networks. It has an accuracy of 95%. And the next one is a hybrid detection technique for skin cancer images. It has an accuracy of 85% and an interpretable skin cancer classification using optimized convolutional neural networks for a smart healthcare system. It has an accuracy of 82%. And these are the literatures we are referred. And the main objective of our method, our paper is introduce a deep learning model for the detection of skin cancer, and which is helps the physicians. And we are using a deep learning model, and that is a pre-trained model, MobileNet V2. And then why we are choosing MobileNet? It is because its efficiency, performance, scalability, versatility, compatibility, and community support. And the first one, we are taken a dataset as HAM 10,000 dataset. It consists of 10,015 images. It consists of 7 different types of skin cancers. In the dataset, the skin cancer images are of different number of images in the each classes. That is, there's IEEC is 327, BCC 540, BKL 1099, DF is 1150, ML is 1113, and NV is 6705, and VASC is 142. And these 7 classes of skin cancers we are classifying. And the first, we are running a feature extraction. The feature extraction is done using a pre-trained model, that is MobileNet V2. The feature extraction is done by 3 levels, that is low level, mid level, and high level. In low levels, we are using a basic patterns, edges, textures, and colors features. And in mid level features, we are using shapes and object parts. In high level features, we are using faces, objects, or other scenes categories in the images. And then we are moving on to image preprocessing. In the image preprocessing technique, we are used to enhance or modify the digital images before they are analyzed for the purpose for the first process. And that in this technique, we are reducing the noise and resizing the image and normalizing and filtering. That is, the normal size of our image in this data set is 450 by 600 pixels to 600 to 800 pixels. That is, we are resizing the image to 32 by 32 pixels. And then the main goal of this resizing is to improve the quality or usability of the images. And then we are using data augmentation. In data augmentation technique is used to increase the size of the data set by applying various transformation techniques. We are rotation, translation, flipping, zooming, etc. we are done. And in also the we have already seen that in 7 classes the image is not balanced. So we are balancing our data set by giving a number of samples as 6,500. And this is architecture of MobileNet V2. It contains a convolutional layer, a depth-wise 3x3, and with a ReLU activation function and convolutional 1x1. And it is at stride 1 and stride 2 blocks as it is. It is first one is stride 1 and second one is in stride 2. And this is the block diagram. As we already said, we are using a dataset has HAM 10,000 dataset, and we are first pre-processing the data. Pre-processing and the data augmentations are already done. And then we are training and validation our data use our pre-trained model MobileNet V2. And MobileNet V2 here we are tested with some testing images. And this trained model classifies the images into which it's 7 classes. And also we analyze the performance metrics as accuracy, precision, F1 score, and recalls we are analyzed. In addition to this, we are not only taken a pre-trained model, we also add some layers into the end of this pre-trained model, that is MobileNet V2. We add some layers to increase the accuracy of our model. That is, these layers as a flattened layer, dense layer, dropout layer, and batch normalization and activation ReLU. These layers were also added in the end of our MobileNet V2, that is pre-trained model, to increase the accuracy and increase the outputs efficiency. And this is the epochs of our training. And in this, from this epochs of training, we are done a 50 epochs. And in the from this 50 epoch, we have got a training loss as 0.3%, and accuracy as 92%, 98%, and validation loss as 1%, and validation accuracy as 95%. And while testing, we have got a result as test accuracy as 95% of test accuracy. And in this is a classification result of the proposed model with the different 7 classes, the 7 classes with the precision, recall, F1 score, and support. And the average accuracy as 95%. Total accuracy we have got is 95%. This is the result, that is training and validation accuracy graph and training and validation loss graph. We can see that the graph is increasing, and that is accuracy is increasing and the loss is decreasing as we train our model. And this is the confusion matrix. In the confusion matrix, we can see that diagonally it shows a result that it classifies the images very correctly that it has more accuracy, that is 95%. But we are given some random images, and from this result we can see that the first we are given a BCC input as an image, then it shows a BCC with confidence of 99%, and in some it shows in melanoma, that next is it shows it is a melanoma with 100% of result. Then it is a comparison with the related works. We are compare with the literature review we are referred, and but from the comparison we are analyzed that our research has highest accuracy than other methods. And it advantages, it has high efficiency, model size, and high accuracy, versatility, and scalability. And disadvantages is limited representative power, limited adaptability, sensitive to hyperparameters, not suitable for all tasks, potentially trade-offs in performance. And the application is mobile net, embedded vision, IoT and edge computing, autonomous vehicles, healthcare imaging, smart retail and marketing, environmental monitoring. And the future scope is we can improve this model by ensembling by different many methods where models, or we can add some more new pre-trained models, and by ensembling this we can also increase the accuracy of our model. And we can train, then we can use a specific domains, on-device learning and federal learning for multimedia applications. We can use it as future scope. These are the references we are taken. Thank you.
Thank you, ma'am. Now we'll start question and answer session. Sohan sir, please.
Okay, this is a nice work and you have presented well, but I have some fundamental questions. Can you go to a table where you have compared with other network? Yes, so you are comparing with only mobile net, right?
Yes, yes.
Why that is so? Only to check the lightweight model, that's it.
No, we are already done many researches using ResNet, DenseNet, VGG, exception, many more nets we are using, and we prepared many researchers where we are done with many researchers where another papers also. But we are in this paper, we are particularly concentrated on mobile net, and we are trying to improve the accuracy by using mobile net. That is, we added a pre-trained, we are taken a pre-trained model as mobile net, and by how we can increase the accuracy using mobile net. That is our main research. That how we are added at the last of the pre-trained model some layers. That is why it increased the accuracy. That is, we are added some layers in the output of this mobile net layers, that it increases the accuracy.
So you have taken the pre-trained model and you did a transfer learning to train those last layer, right? And you have,
yes, yes.
You have gone for fine tuning.
Yes.
Okay. Okay. So, and how is the performance with respect to the other networks? Say, for example, exceptions or inception models, other networks that are popular in the domain? Or is there any specific network which is proposed only for this type of tech applications?
We done with many networks, that is DenseNet exception, but particularly by analyzing the different papers and this, we thought that we could do this with mobile net. Why there is not an increase in the accuracy using mobile net? We have done another paper using DenseNet also. It has also an accuracy, but we thought that there is not paper that increases the mobile net has highest accuracy. So we are trying to improve the mobile net. We are particularly taken mobile net. It's because of its computation and its memory, its scalability. That is why we are taken particularly mobile net and try to increase its accuracy.
Okay, fine. No more question from my side.
Thank you, sir. Thank you, ma'am. You can stop your screen share. Now, paper ID having 2 to 6, you can start your presentation by sharing your screen.
Yes, sir. So is it visible, sir?
Yes, ma'am, it's visible. You can start
Yes, sir.
now.
Thank you. Yeah, thank you. Sir, I am Bhavana. Good afternoon, everyone. My title is Utilizing Blockchain Technology for Health Insurance in the Healthcare Sector. So these are my contents. Coming to introduction part, actually blockchain technology. So nowadays,
Ma'am, your
sir,
screen, your slide change, but here not visible.
one second. Sir, is it okay, sir?
No, ma'am, it's still now not visible.
Sir, is it visible, sir? Introduction part.
No, ma'am.
Once.
Only title page is visible.
So now, sir.
No, ma'am. You can unshare it and share it again.
Okay.
Ma'am, share it again.
Oh, one second, sir.
Ma'am, if you need some time, you can move it to next
No,
participant.
sir. I'm ready, sir.
Okay, ma'am. Please make it good. Please share the screen, ma'am.
Yes, sir. I'm doing, sir.
Ma'am, you take your time. We will going to the next participant. After you can join. Okay, ma'am.
Yes, sir. Okay, sir.
Okay. Now paper ID having 2 to 9. You can start your presentation by sharing.
Okay.
Ma'am, you can turn off your camera.
Sir, is this my voice audible?
Yes, ma'am, it's audible. You can share your screen and start.
Okay. Is it visible, sir?
Yes, ma'am, it's
Okay.
visible. Can you
Yeah,
scroll
okay.
one slide?
Sir, shall I start now?
You can start.
Yes. Good afternoon, everyone. Today, I'll be presenting on innovative approach to countering DOS threats in wireless server network. That is, denial of servers are using machine learning strategy. That is, both are effective and minimalistic. So these are my content we are going to discuss now. Coming to the introduction. Apart from going to introduction, I'll just background the project. Wireless sensors are crucial for various applications from
I think your
environmental
site is not getting changed. Maximize this presentations.
Now it's okay,
Yeah.
sir?
Yeah, fine.
Yeah, okay. Now I'll discuss about background. Wireless sensor network are crucial for various applications, particularly from environment monitoring to smart sites. However, their reliance or limited sources make them vulnerable for DOS attack, which can severely dispute their functionality. Traditional defense mechanisms often require sustainable computation power and energy, which wireless sensor network cannot afford. So I'm coming to the introduction. As we all know, BWS are highly vulnerable to malicious activity due to their limited resources. Our goal is to protect this network without overbuilding their computation capacity. To achieve this, we are integrated minimalistic machines learning technique. That is, this technique will help us to detect and mitigate DOS attack by analyzing essential features from network traffic patterns. These approach allows us to accurately identify and suspicious activity with minimal computation overhead for sensor nodes. So these are about introduction. Next, we coming to abstract. Our main approach focus on extracting key features from network traffic pattern to accurately detect DOS attack. This method is designed to be overweight and reduce the computation and resources demands on sensor node. These are the literature review which has been done. So, coming to the objective of the product. Here are our main objectives. That is, I'll overthrow main like investigation see vulnerabilities. We aim to create a machine learning based method that detect and make its DOS attack efficiently without overburdening the sensor nodes. Next, coming to the second point, which is feature extraction. Feature extractions are the essential features from network traffic pattern. We can accurately identify abnormality behavior that indicate a DOS attack. So coming to third one, which is validate methodology. Another thing is validate methodology is we test our approach extensively using a real world WS dataset to ensure that effectiveness and efficiency. Finally, coming to scalability and adaptability. Finally, we ensure that our solution we can scale and adapt to different WAS and setup and various attack sensors. So this is our block diagram where sensor node first with the features at what are the process we going on as carried out listed here. That is data collection, feature extraction, selection versus extraction. We introduce the machine learning classification is decision making for DOS attack. Whenever the attack has been recognized, alert has been generated. So overcoming our now our challenges based on our challenges go through the proposed model using XW boost. What is the main disadvantage as it has is complexity. That is XW boost is a complex then decision tree. We do not we don't want to complicate such kind of algorithm using this project. Require careful tuning for hypertension and longer tuning times, which can be drawback. Another thing is resource intensive. Resource intensive, it demands significant computational resources, including memory and processing power, make it less ideal for resource environment like WSN. A third one is a black box nature. Black box nature, that is extensive boost model are harder to interpret due to their ensemble nature. This makes it challenges to understand the reasoning behind specific prediction. Sorry. Finally, um, potential overfitting. Potential overfitting can be prone to overfitting, especially with large data sets and a complex feature space, which might reduce generalization performance basically. So these points are highlighting the limitation of using boost XT boost in WSN motivating the need for more effective and interpreting solution. So coming to the proposed method, now I would like to introduce the proposed one is decision tree and why it is well suited for WSNs, that is wireless sensor network. Basically, main reason is simplicity. Decision trees are simple and more interpretable than excessive boards, make them easier to understand and implement. So second thing is low computational overhead. They require fewer computational resources for training and inference, making them ideal for resources constrained environment like WSN. So another thing is transparent decision making. Decision tree provide a clear and transparent decision making process, which make it easy to interpret the model logic and understand feature importance. Reduce risk of overfitting. That is decision when approximately irregularities are happen, decision tree are less prone to overfitting, leading to more robust performance, especially with limited data. Essence of implementing. They are straightforward to implement and tune, required fewer hyperparameter compared to complex ensemble method like existing one. So these advantages make a decision tree an excellent choice for enhancing the security of wireless sensor network against denial of service attack. So this is the overall accuracy predicted by comparing various algorithms.
Ma'am, it fast. You
So,
only what's left.
okay. I'll go to complete this. So, coming to conclusion, to conclude our project, it represents a significant advantage enhancing the security wireless sensor network against or denial of service. We developed a minimalistic machine learning strategy to seem integrated into um, wireless sensor network infrastructure. These systems provide real-time monitoring of network traffic while maintaining scalability and resource efficiency. So, importantly, the minimalist nature of our approaches ensure effective production with minimal operational overhead, which is crucial for resource constrained through the environment. So thank you for the attention. These are the projects overview. They are the future scope. These are future scope, mainly optimizing algorithm efficiency, adaptive learning technology, technique use it dynamic approach can enhance the network ability to identify and migrate. So another final one is resource constraint implementations. So these are the future scope which have been mentioned, which has been advanced with ensure our system remains effective and efficient as SW and continues to evolve. So thank you. They are the references we are carried out through the projects.
Thank you, ma'am. Now we'll start question answer session.
Yes.
So one,
Yes.
sir. Please.
Yeah. So can you please go to that accuracy prediction results?
Yeah. Yes. 1 minute.
Yes. So what do you mean by prediction here? These are the test result or?
We have first of all we calculated using decision tree and we compared to the overall performance of with other algorithms, sir.
So basically, what is the data sets you are using?
Sorry, sir.
Which data sets you are using?
That is a real-time data set, sir. We are collected real-time data sets, sir.
Oh, okay. So during the training, and so you have a training data sets, right? So online training you are going for, and during the case you are going for testing.
Yeah, yes, sir.
Okay.
Yeah, testing and training data sets has been listed in our paper itself, sir. We have clearly listed the training and testing data as well as. So for the presentation, I have compared the overall algorithm versus our predicting advantage of over existing versus advantage of our projects, sir.
So these are the well-known technique like decision tree, k-nearest neighbors, RF.
Yeah, yes.
So what is the contributions in this respect? Because these are the well-known machine learning techniques that you have used to your applications. I want to know what new things that you have done. So
New
you can go to the
success,
architecture diagram. Can you go to the architecture diagram?
yeah, yes.
Yes. So like, yes. So this is your architecture, but this machine learning classifier, you can take anything, right? So what, right?
Sorry,
You have used.
sorry.
So there is a machine learning classifications, right? So there you are using different type of classifiers.
Yeah, sir.
So that's why I'm asking. So what is the novelty here?
Yeah, yes, sir. I'll say. First of all, the first one is a minimalistic machine learning approach, sir. We are using traditional methods, so complex resource intensive our users. It will be overhead their resources, make it to which suit for constrained environment of wireless network. Another thing is real-time detection and mitigation. So compare from before like the existing papers, we have researched in real-time applications focusing on real-time monitoring detection for DOS attack by extracting essential features from network traffic patterns. Another thing is another novelty, which is seamless integration. That is, it's mainly designed smoothly to existing WSN infrastructure without requiring significant hardware upgrades, which is significant to improve over a demanding solution. So this is the main novelty I'll approach you. Another thing is scalability and adaptability, sir. So the proposed solution is both scalable and adaptable, allowing it to handle diverse wireless service network setup and evolving attack scenario effectively, sir. So this innovation represents a significant over the projects, sir, combining effectiveness with practical resource management.
Yeah, it's a nice work. Anyway, I don't have any more questions.
Okay, sir.
Thank you, sir. Thank you, ma'am. You can stop
Thank
sharing.
you. Thank you. Okay. Thank you.
Now paper ready having 2:30. You can start your presentation.
So 226 is ready, sir. Shall I?
226.
Yeah.
Okay.
Previous.
226. You can
Yes, sir.
share the screen and start presentation.
Yes, sir.
Please once change your screen slide.
Yes, sir. Sir, is it visible, sir?
Yes, ma'am, visible. Try to
Sir,
change the slide. Yes. It's okay. Okay, ma'am.
Yes,
Ma'am,
sir.
start, please.
So good afternoon, everyone. I'm Bhavana. My title is Utilizing Blockchain Technology for Health Insurance in the Healthcare Sector. And these are my contents I'm going to present. And before we enter into the blockchain, so without blockchain technology, the traditional healthcare sector could be affected by so many reasons. That is, the major reasons are there is no data privacy, false claims, and administrative inefficiencies. So those things can be identified with the help of blockchain technology, because blockchain technology has so many unique features compared with other technology or other models. Inside the blockchain technology, we have decentralization property, immutable properties, smart contracts, consensus algorithms. So with the help of those things, we can identify the issues existed in the traditional techniques. So this is coming to the abstract. While sharing the health insurance sensitive data, so we have to protect the data in order to avoid unauthorized access. So with the help of blockchain technology, so we can secure our data and securely sharing the data from one end to other end. So these are the literature reviews. In literature one, actually they were discussed about peer-to-peer networking technology. So under this paper, they were discussed basic principles, architectures, and applications. And second review, actually they were focused on data handling within blockchain architecture. Under this paper, they were discussed data structures, transaction processing mechanisms, and storage schemes. And third one, we'll discuss about, that is, they were analyzed various security aspects of blockchain systems. So inside this paper, they were discussed various consensus mechanisms, smart contract vulnerabilities, privacy concerns, and 51% attack. And coming to fourth paper, so they were conducted an intensive literature review to identify key themes and trends in blockchain research papers. Coming to fifth paper, actually they were conducting a comprehensive study on consensus mechanisms and mining management in blockchain network. So this is my objective. So through blocking, that is, we are integrating one of the consensus algorithm available in blockchain technology with the healthcare sector. So through that integration, so we can enhance data security and privacy in health insurance transactions, and we can reduce instances of false claims through immutable record keeping. So immutable means once the data is stored in the distributed ledger, so we cannot do any modifications. So this is called immutable. And next, so we can streamline administrative process of for insurers and healthcare providers. Also, we can increase the transparency and trust. Then we can implement smart contracts to automate insurance process and the claim settlements. So this is the architecture flow. When we want to use practical Byzantine fault tolerance in blockchain technology, so we have to prepare those things. First, we have to do transaction initiation. That is, client will send the request to the primary node, that is miner node. Then they will do proposal. Then we have pre-prepare phase, prefer. I will discuss one by one. So here, the existing work is proof of work. Actually, POW is the one of the most fundamental consensus algorithm used in blockchain technology. Due to high energy consumption and slow transaction processing, it will create some issues in health insurance sector. So now we are moving from proof of work to proof of practical Byzantine fault tolerance. In proof of work, whenever we want to add any new node to the blockchain network, so first the miner, that is actually a special hardware, have to do some have to solve some puzzles. So puzzles are nothing but complex mathematical problems. Whenever they solve the complex mathematical problems, they will get the hash value. So through that hash value, they will add a new block to the blockchain. So once he finds a new hash to the new block, he will broadcast the hash and the data or transaction to the entire network. So other miners, that is other validators or other nodes in the network, should validate the transaction. Once the transaction is valid, so they will give consensus about the new block and send it to the miner. Then the miner will add a new block to the blockchain. So this is how POW works. In POW, when we want to solve a complex mathematical puzzle, we have to provide more resources and we have to spend more time. In POW, actually, one of the drawback is 51% attack. That is, a single entity or group of entities control a majority of network's mining power. So they can be severely affected by the 51% attack. Whereas in proposed algorithm is practical Byzantine fault tolerance, and this is also one of the consensus algorithm available in blockchain technology. In PBFT, we do not get any consensus among other nodes in the network. We can directly send our request. That is, we can directly send our transaction to the primary node. Then the primary node will do. Primary node is nothing but our miner node. Miner node is a special. It will do mining process. Mining is nothing but validation. So through that validation, they can validate the new block. Once the new block is accepted by all other nodes in the network, so they will add a new block to the blockchain network. In PBFT, they will not require any consensus. That is, they will not do any complex mathematical puzzles. So they can directly add a new block to the blockchain. Before adding a block to the blockchain, so they will get a agreement from all other nodes in the network. So these are the benefits of using PBFT in blockchain network. So with that, we can definitely increase the security. So next, these are my output. Actually, the accuracy, precision, FN score, and recall are basic parameters. That is, with that parameters, we can evaluate the performance of various applications like fraud detection, transaction classifications, and anomaly detection. So accuracy can be calculated from, that is, correctly predicted observations to the total observations. Here I am getting 0.95 accuracy. And for precision, actually precision can be calculated by, that is, the correctly predicted positive observations to the total predicted observations. That is total predicted positive observations. So here I am getting 0.92. So next is F1 score. Actually, F1 score is nothing but the average, that is the weighted average of precision and recall. And here I'm getting 0.96. So next for F1 score, I'm getting 0.94. So here I'm comparing POW with the TBFT algorithm for healthcare sector. And my conclusion, that is we are integrating PBFT algorithm into the blockchain technology in order to improve overall security in healthcare sector. And also we can automate the claim processing. Without getting or without solving any complex mathematical process, they can add a block to the blockchain. Once the block is added into the blockchain, we cannot modify the block that are stored in the distributed ledger. So the future scope is with that smart contracts. Actually, smart contracts are nothing but some digital contracts should be raised among participants in the network. So through that smart contracts, we can enable the use of automating the insurance policies, premium payments, and the claim disbursements. And with that decentralized health insurance platforms, the policy holders and providers can directly contact without introducing any third party or without introducing any centralized server. And third thing is interoperability and collaboration. So with that, we can share data, and interoperability can be achieved between healthcare providers, insurers, and the patients through blockchain technology. So these are my references. Yes, sir. Thank you.
Thank you, ma'am. Now
Yes,
we'll
sir.
start question and answer session.
Yes, sir.
To Sohan sir, please.
Yeah, can you please go to your literature survey part?
Yes, sir.
So second one, when it is published?
Sir?
Second paper, when it is published, IEEE transactions K.
Yes,
Second
sir.
paper.
2018, sir.
2018.
Yes, sir.
Why it is published? IEEE transactions in?
Yes, sir.
Which transaction? Which transaction?
Sir, I think Springer, sir.
No, second one, a data processing view of blockchain systems.
Yes, sir.
Why it is published? Exactly, can you tell me the journal
I
name?
I think 2018.
Can you please check? You can check also, right?
Yes, sir. Yes, sir. I will check, sir.
Second question is, like, did you compare with this? Did you use this paper in your work anyway?
Yes, sir. Yes, sir. I'm using for my PhD work.
So can you elaborately explain how you are incorporating this technique to your this paper?
Sir, actually, I'm concentrating on healthcare insurance system. POW is already existed, sir. So now I'm going to use PBFT in my work.
Okay.
So, yeah.
Okay, please go to the next slide.
Yes, sir.
Next one.
Yes, sir.
So these are the you discussed about limitations and methodology, all those things. How your techniques are tackling these? Specifically, go to the block diagram and explain me how your methodology is tackling the limitations of this existing work.
Sir, actually, when we are using proof of work in blockchain technology, whenever a client wants to add a new block or a new transaction to the blockchain, one of the node among the network will act as a miner, sir. Miner is nothing but it is a special hardware or special computer. So they will get a input from the client, and actually the task of miner is to perform mining. So mining is nothing but they have to find a hash value. The calculated hash value should be lesser than the difficult level, sir. If it lesser than the difficult level, then they will be act as the minor. That is, they solved the problem. Whoever solved the puzzle, so they will be call it as minor. Then he will send the data and hash value to the other nodes in the network. Again, the remaining nodes in the network will do verifications for the received transactions. If suppose I have a 10 nodes in my network, from 6 to 7 members agreed the transaction is okay, then they will send the consensus to the minor node. If he receives a consensus from majority of the nodes in the network, they will be getting the strong confirmation about the new transaction. Then he will add a new transaction into the blocks, and each and every block will be added with a hash value. Suppose if he failed to solve a hash value, the process will be given to other node in the network. So in POW, actually, whenever we solve a puzzle, the miner will get a benefits like bitcoins. Whereas in PBFT, we do not do any validation processes. That is, we do not need to solve any complex mathematical puzzles.
Okay, can you go to the next slide, please? Where you have shown the results. Next.
Yes, sir.
We have concentrated about the graphical representation of or waveform of IoT security devices with using wireless sensor network. So the importance of IoT and wireless sensor network, the devices become increasingly relevant, enhancing connectivity in various applications such as smart homes and industries and hospital management. These kind of things we have used the IoT devices, and also we have been used wireless sensor networks in playing a vital role. It's seamless to exchange data between the interconnected systems. So these kind of things we have importance in the IoT devices and wireless sensor networks, and also data integrity. In data integrity, these things are ensuring a data integrity and security and transmission within wireless network is a crucial things. So that there is a lot of vulnerable things and threats is and from malicious acting and malicious things we have faced in the outside networks. So that's also data integrity and security concerns we have prepared these papers. So, and also institution directions, IDS, implementing robust IDS is essential to protect WSN from potential instructions. So IDS acts a crucial defense mechanism to detect and respond to anomalies and threats. So goals of IDS is the project aim is to develop innovative IDS strategy tailored to IoT enabled wireless sensor network. Objective and including surveillance, anomaly detections, intruder detections, shifting response mechanism. These kind of things we have included this paper, and also enhanceability of reliability and trustworthiness. So this is a project completely seek instill confidence and reliability trustworthiness of interconnected ecosystems, and also ensuring a security of wireless sensor networks contributes safer, more and resilience to IoT land spaces. So this technically this projects involve relationship between advancing technology and maintaining security. So these things we have concentrated in this project. So we have go through we have survey these papers for preparing this paper. So our objective of paper is develop comprehensive and understanding unique challenges and vulnerabilities inherent in IoT enabled wireless sensor network. So design and implement of effective institution detection system is tailored specified in wireless sensor network, and also in the infrastructures without compromising network performance or scalability. It's conducted through the testing and evaluation of IDS under various simulated attack scenarios and access effectiveness.
So reliability, establish protocol and procedures for real-time response, mitigations and strategy through potential institutions, and preserve the data security. So our architecture is data collection, feature extraction, decision tree algorithm. We have used the training models and integration with wireless sensor network infrastructure and real-time monitoring, alert generation for institution detections, so optimization tuning and security measures and testing and evaluations. So this is our complete architecture. Now I hand over the session to Dr. Sasireka ma'am. Sasireka ma'am.
Yes, sir. I'll continue. I'll carry on.
Okay, thank you.
So let me discuss about existing work of our project. Can you change the slide, please?
Yes.
Yeah, okay. First one is complexity. So complexity, which is enable technique made up of multiple decision trees. While it enhances accuracy, it can more complex to implement and interpret compared to single decision tree. So managing and optimizing its parameter is the challenging one. Another thing is resource intensive. Another research intensive is require more computational resources and memory, especially the number of free increases. This can be limit its use resource. Yes, overfitting. Overfitting. Random forests may also be prone to overfitting, particularly in the noisy and imbalanced data, which is common in IoT scenarios. So these are the limitations highlighted in the project. Needed to a more effective interpreted model for our proposed one. Now coming to explore the proposed decision tree, which is our benefits of our project. First one is interpretable. Decision tree provide a clear and intelligent decision-making process. That is, it's transparency, like a stakeholder under how the reduction is be happen, enhancing trust and the easy involved. So another effective one is simplicity. Compared to more complex, straightforward to implement, and it very much required fewer computational resources. So I think this would be preferred one. Other thing is scalability and feature importance. And particularly, this help priority security and measure to allocate resources based on most critical data attributes. That is, which is effective one. Now coming to the sir, can you move the slide?
Yes, sir. Yes, ma'am.
Like result validations. Can I present, sir? Can I share now, sir?
Objective, or can I move it in architecture, existing random model for us?
So it's not moving. Actually, the slide's not moving. It will be in literature review only, sir.
1 minute.
I'll share, sir. No, I'll share.
Okay, ma'am.
So it's visible. Sir, is it visible now?
Yes,
Yes, yes.
yes, ma'am. It's visual.
Okay. So I completed objectives are done. Which is
Can you view fast?
yes.
Time is around 2 minutes only left.
Okay. I'm going to complete, sir. So this is our accuracy predictions. Which is model. Overall, we are trained and test various models. But now we listed along only the overall accuracy of our model. That is, using decision tree, we have acquired 0.99%. That is a maximum of 100%. So it will be our accuracy predictions. Next, coming to the conclusion. Our project, which employed an intrusion detection system, has successfully tackled the critical challenges of protecting sensitive data in IoT. By leveraging advantage of many algorithms, it provides real-time monitoring and analysis. This system adaptable to dynamic nature of environment, that is especially in IoT environment, ensuring continuous production against evolving threats. Another thing is our IED framework not only enhance the resilience, but also build trust and reliability in critical sector like healthcare, agriculture, smart cities, and industrial automation. So looking forward, had going research and development will be essential in future strength. That is, the future scope of our project is enhanced detection algorithms. So another thing is decentralized security architecture, which is against tracked attack and minimize the impact of intrusions. Another thing is integration with emergency technology, that is multi-layer approaches to secure the network. So that's all. These are about references we have carried out. So that's also. So thank you for your
Thank you,
kind
ma'am.
attention. Yes, sir.
Now we'll start for question and answer session. Over to you, sir.
Yes.
Sevan, sir.
Yes, this is indeed a nice presentation. But what is your novelty? Because such kind of work already has been done elaborately, right?
Yes,
Extensive
yes,
work.
sir.
So, what way your work is
So it
different?
yeah, yes, sir. I'll explain. So our project has several novelty that I'll keep formatting any 5 points, sir. First one is minimalistic machine learning algorithm. That is, apart from comparing big algorithms and actually we calculate many accuracies, but using minimalistic algorithm, unlike traditional methods, like we often complex and resource intensive, but our algorithm is approach designed to lightweight, ensuring it performs efficiently in high security purposes. Another thing is real-time anomaly detections. So in our intrusion detection system, it involved advanced anomaly detection technique to monitor network traffic in real time, sir. Another thing is seamless integration, which is we have designed our IEDS framework in integrated smoothly into existing wireless network setting without requiring significant hardware upgrades. So another thing is adaptive mechanism, which is it ensures the system remains effective and up to the date is dynamic IoT environment. It monitor everything in challenging is up to date for real time, sir. Another finally focus on practically. Practicality is which is nothing but our project emphasize practical implementations which operationally effective, making suitable for critical applications in sector like various advanced technicals which is available in real day-to-day life as healthcare, smart cities, and industrial automations.
So,
So
do you have
we
quantitative
think.
evaluation? Do you have any quantitative evaluations against all these statements?
Sorry, sir, I'm not getting you.
So, do you have any quantitative evaluations against these kind of statements that you are giving? For example, any comparison, runtime,
Yes,
throughput,
sir.
all those things?
Yes, sir. We have already in paper we have listed we in training data set and its comparison between other algorithm, that this various algorithm with upcoming algorithm. But now in the presentation we just simply lay out the overall accuracy of other algorithm versus our proposed algorithm alone, sir. So we think that the security and reliability demonstrate the significant advantages in intrusion detection systems.
Okay, thank you. Thank you. No more question from my side.
Okay, sir. Thank you.
Thank you, sir. Thank you, ma'am.
Thank you. Thank you.
With this, we can
Thank you, sir.
stop this session.
Okay, okay. Sir.
Thank you for
Thank you
this
for your time, sir.
valuable
Thank
time,
you.
sir. Thank you.
Thank you.
Thank you.